Hey, what's up guys? In this video, I'm going to show you how to find the proportion or the area under a density, normal density curve. So I have a few examples to show you guys, and I'm going to show you how to use the graphing calculator TI-84 to find that proportion. So first, let's look at the example. In context, what are we looking at? So in the box here, in the rectangle, it says an analysis of the top songs on Spotify over a 10-year period reveals that songs' length follow an approximately normal distribution with a mean of 220 seconds, and a standard deviation of 26 seconds. So it's very important that we know this distribution is normal. So we look at the keyword normal, approximately normal distribution. So that means that we do have a bell-shaped curve, and you can actually see one here. And looking at that bell-shaped curve, the mean right at the center, so this mean right here is going to be 220 seconds. And then we know they say that every standard deviation is 26 seconds. So let's look at one example to find the proportion or the area under that density curve. So let's try this example. It says, what percent of songs are shorter than 181 seconds? So we have to know, first of all, what are we looking for? So the question is what percent? So we're looking for a percent. The calculator will give us a proportion, but we can change that to a percent, okay? Also, keywords that will help us know what we're looking for is, well, we're looking for the percent that is shorter than 181 seconds. To give you guys a visual, we can draw a density curve and we can label what we're looking for, and also you guys can shade the area under the curve that we want. So you guys can draw the density curve, a bell-shaped curve. It is a approximately normal. In the middle is your mean, so we have 220 seconds. We can label the density curve just to remember what we have. So capital N means normal distribution. Mean is 220 and the standard deviation is 26. So the number or the value that it's given to us, the number of seconds given to us is 181. So if the mean is here 220, well, 181 should be somewhere on the left side, somewhere below 220. So you guys can approximate. We just label, I'm going to say right here, and this is 181 seconds. So we want to shade the side on the left side of 181 or the right side of 181 to know what area we want. Since it says shorter, that means less than, or it means fewer, or it means below, but it has to be something less than 181. So the numbers less than 181 are on the left side of that value. So I'm going to shade this area, all the area on the left side. Now this is the percent or proportion that we're looking for. So we want to find out the actual proportion. I'm going to put a question mark right here. We don't know what that area is. So let's look at an interval of what we're looking for. Yes, we want from 181 and less, but keep in mind that this density curve, the area, it keeps getting smaller and smaller. It gets closer and closer to the horizontal line. So you can think of the number line. So it keeps going and going and going all the way to negative infinity. But in the calculator, we do not use negative infinity. We can use negative 10,000, or you guys can use a very small number, negative 1,000. And that's going to give you guys a very good proportion or percent for your answer. Since we want this area, my lower bound is going to be my negative 10,000, not the infinity. So we have to go all the way to the left side, but the lower bound is going to be negative 10,000 all the way to 181. So let me show you the calculator and have to find that area which is shorter than 181. In the calculator, if you want to find the area less than or shorter than some value on the normal distribution, we want to find the proportion or the percent or the area under the curve. If it's normal distributed, we can use the normal CDF. So you guys go to normal CDF, which is second bars, and we go here. Number 2 is normal CDF. Now, when we want to know what is the area below we're going to start with the low end of our area. So the low end is going to be negative 10,000. That's going to be our lower bound. So we start with negative 10,000 and we want to go all the way to 181 seconds. So in context, we are using seconds. So if we want to find the percent of songs that are shorter than 181, so this is the calculator. This is what we're telling the calculator. We want the area from negative 10,000 all the way to 181,000. The mean is 220 seconds. Standard deviation is 26. So that's going to give you guys the area from this lower bound to this upper bound, which means less than 181. And my proportion is 0.0668, and you round to 4 decimal places. So we stay at 0.0668. So now that we know what is the proportion, we just change that to percent and we write it in context of the problem. So we are going to say about 6.68% of songs are shorter than 181 seconds. The next example I want to show you is number 6 on the screen. It says Ed Sheeran and Beyonce made the list with the song Perfect Duet, which is 260 seconds. What proportion of songs are longer than Perfect Duet? So here we're actually looking for something bigger, something longer than, and they say the value, the song is for a Perfect Duet is 260, so we're looking for more than 260 seconds. Here they don't ask for the percent, they just want to know what is the proportion. So we don't have to turn the decimal into a percent, but it's always very good idea to draw your density curve. So make sure you guys do that. Always draw a density curve. In the middle, we're using the same mean, so 220. 260 seconds, which is the length of the song, is going to be somewhere over here. I'm just going to label right here 260, which is on the right side of the mean. So you guys will have to know what side to shade. So I am going to shade, let me just put a line here on top of the 260. Since it says longer, I want to shade the right side of 260, but because everything on the right side is going to be more, longer, bigger than 260 seconds. So the proportion that we're looking for is this small area right there, and we can use the calculator to find that area. But we do need the lower bound and the upper bound. So let's look at the area again. The area from left to right, it starts at 260 and it keeps going and going and going. So remember this area, this density curve, it keeps going to positive infinity to the right, but we don't need to use infinity in the calculator. We're going to use positive 10,000. So my lower bound is going to be 260 all the way to positive 10,000, and then you guys can find the proportion. In the calculator, to find the proportion or the percent that is more than 260 seconds, which is just going to be the area under the curve when we know the distribution is normal, we are going to use the normal CDF function. So to do that, we go to second and we hit bars right here. Notice option number 2, you guys have the normal CDF, so we click on that one. We do need the lower bound, upper bound, the mean, and the standard deviation. I am not using z-scores. I'm going to use the values of the data. So here in the question, they give us the mean of 220. They give us a standard deviation of 26. And we want to find out what proportion is more than 260. So what that means is we're going to start with the 260. And we are going to go all the way to 10,000, which is positive, and we are going to put in the mean, which is 220, and the standard deviation is going to be 26. So once you have that, which is the data or the values of the data, Notice that we're telling the calculator I want to find the proportion or the percent or the area from 260, the value in context this is seconds, so 260 seconds all the way to positive 10,000 seconds. Obviously, in reality, we don't have anything that is 10,000 seconds long, but we want to find all that area, more than 260. So be careful, you check the mean and the standard deviation of your distribution. So once we hit paste, we hit enter, then that's going to be our proportion. So this proportion, this decimal is going to be about 0.0619, and you can actually round to 4 decimal places. So the 6 next to the 9 is going to make that into a 20. So 0.0620. So now you just write your answer in context of the problem. So here we're going to say about 6.20, you can round to 6.20% of songs are longer than perfect duet. The next example, it says Taylor Swift has many songs in this list with widely varying songs length. We Are Never Getting Back Together is only 193 seconds, while Endgame is 245 seconds. What is the proportion of songs that are between these two songs? So we are looking for a proportion, and we have between, we want to find the proportion between these two songs. So when you look at the density curve, just imagine that you guys are looking at those two values, and we have the mean in the middle. So the mean will be 220 seconds. We want the 193. So 193 more or less is going to be around here. So this is 193 seconds. And the 245 seconds somewhere over here. So after 220, that's going to be 245 seconds. So what we want is what proportion, what area is between those two songs. So this is the area we are going to find, all of this area in between. So this, you guys need to use the lower bound as 193 and the upper bound is 245, because we want from this value to this value. So you guys use those two numbers for the lower bound 193 and the upper bound 243. So I'm going to show you guys how to use the calculator. Looking for the proportion between two different values in a normal distribution. So we want to find out what percent, what proportion of songs are between 193 seconds to 245 seconds. Well, we do the same thing. You guys go to second, bars, and we go to normal CDF. This one here is going to give you guys a proportion, normal CDF. Now my lower bound is going to be the low value that we have. So we are looking for the area between, or the proportion between 193. So that's the lower bound, lowest value, and we want all the way to 245 seconds. So we're telling the calculator we want the area, the proportion between those two values. Make sure you guys check the mean and the standard deviation. So for this example, the mean is 220, standard deviation is 26 seconds, and you hit paste, enter, and we round to 4 decimal places. So the proportion between 193 and 245 seconds is 0.6823. You can round to 4 decimal places. So now in context of the problem, you just write your answer, your conclusion. So we say the proportion of songs between 193 seconds and 245 seconds is 0.6823. In the last example I want to show you guys for this video, it says many artists are paid on streaming platforms according to how much time people listen to their songs, which encourage them to make longer songs. How long should one artist make a song if they want to be in the 10% of the longest song? So this one is actually going backwards. we're not looking for the proportion, we are not looking for the percent. It says here, how long should an artist make a song if they want to be in the 10% of the longest song? So we want to know how many seconds, how long the time, how long should the artist make a song to be in the 10 longest seconds. We have to make sense of the problem. So we start with the tensor curve here. Always label your mean in the middle, and you guys are going to use the percent that is given to us. And notice that we already have the percent. So let me just write down the mean. This is the center right there. And the percent that is given to us is 10%. So we want to find out what is the value that has 10% of one of the sides. But you have to pay attention because this 10%, it says that it has to be on the longest side, the longest song on that list. So if you look at the time and you make sense, let's use common sense here. Well, below 220, that means that it's a short song. Shorter song is on the left side. And more than 220, that's going to be a longer song. So if we want to find the 10% of the longest song, we're actually looking for the top 10% of this density of normal curve. So if you guys label more or less right here, I don't know what this value is. I'm going to put an X right there because that's what we want. We want to know how long the song has to be in order to be on the top 10%. And the top 10 is on the right side of the value. So we want to know what is the song, how many seconds, and it says here there has to be 10% of the longest song. So anything after this value is going to be in the 10% longest song. But we are going to find what is the minimum time to be in that 10%. So this area here, we want to know, that area is given to us. We know this is 10%, or as a proportion, it is, I'm going to put it as a decimal here, 0.10. So when they give us the percent or the proportion and we want to find a value in the calculator, we are going to use a function called the inverse normal. So I'm going to give you guys, I'm going to show you how to use the calculator to find the value using the inverse normal. So to find a value from a normal distribution, not the area, not the proportion, we do not want the percent. We want to find what value represents a specific proportion. Well, first you have to understand the density curve. So looking at the proportion or the area is given, you have to know if it's on the right side of the value or on the left side. So here we're looking at the 10% of the longest song, which is going to be the 10% on the top side of the density curve. So if you guys look at the density curve, well, we need 10% on the right side of the value, which means we will have 90% on the left side of the value. Remember that the whole area of the density curve, normal distribution, is 100%. So if we have 10% on the right side, we will have 90% on the left side. We want to find the value, okay? So in the calculator, the TI-84, that's the one I'm using, this model, you need to tell the calculator what is the area on the left side of the value. So to find the value, we're going to go to second bars and we go to number 3, inverse normal. This is to find a specific value for the density curve, the normal density curve. And it asks you what area are you using and what is the mean and the standard deviation of the distribution. So we need to use the left side of the value. We don't know the value yet, that's what we're looking for, but we know it's going to have 90% on the left side because the question, it did say that we want the 10% of the longest song, so that 10% is on the right side of the value. The longest 10% will be the biggest 10% on the right side. So we need to use 90 on the left side. Make sure you guys use decimals, so make sure you guys use a proportion. So 90% will be 0.90. So make sure you guys turn all those percentages into decimals. My mean is 220 seconds and the standard deviation is 26. Double check your mean and your standard deviation for the distribution. You guys paste, and this one is not percent, this is an actual value. So you can round to 2 decimal places. So 253.32, and in context, it is seconds. 253.32 seconds. And for your conclusion, we can say a song should be 253.32 seconds long to be in the 10% of the longest song. Alright guys, so this concludes my video. I hope you guys like it. You guys can subscribe to my channel, and like always, practice, and I'll see you guys later.